So 1, 3 here, we are going to be kind of called translating expressions, turning words back into math stuff. I don't make as big of a list as I used to with these because I'm like, okay, we know plus and add and all that other stuff. We don't need to go crazy with that. So here's the main words that we deal with. Sum for add, difference for subtract, product for multiply, quotient for divide, and then playing the game with at least and at most. The part here that people tend to forget is the or equal to part. You've got to get that in there. That line has got to be under your inequality arrow, so we're all on the same page. If you see than or from, we'll see that here momentarily. You're either going to flip your expression or you have to flip the arrow. It's one or the other. And then is less than is going to refer to an inequality, not equals, like it does a lot of the time. But we're going to see that. We're going to see all of those things. So, a couple basic ones to make sure we're clean on that. A couple of applications, and we're good here. So, the sum, I like to make little notes as I go here. The sum of twice a number, not the square of a number, but twice a number, and 3 is at most 14. Okay. The sum, so we know we're going to be adding something. Twice a number, okay, not the square of a number. So I don't want x squared, I want 2x. And 3, so add up those two things, is at most 14. So it can be less than 14. It could equal 14. But it can't be more. So when you're trying to figure out the arrow, figure out, if it's at most, well, it has to be less than or equal to when you're looking at that or something like that. So just kind of think it through for a minute and see if what you wrote makes sense. So let's see. Quotient. And again, especially Monday morning, you're going to have to holler at me if you need me for something because I'll get rolling. Of 9 and x. Okay, you have choices here. It is perfectly fine if you wrote 9 divided by x because that's what a quotient is, okay? Is at least, at a minimum, greater than or equal to 4. If all you're doing is writing an expression, that's fine. If you are having to solve the expressions, though, when you get done, I would say when you're doing division with these, making your division a fraction, 9 divided by x is greater than or equal to 4. Those say the same thing. This is much easier to deal with solving wise visually than doing it the other way. So just something to consider when you're doing that. And again, most of them won't be this complex. These are just the tricky ones I want to make sure we touch on. Now, I'm going to freeze screen here for a moment. I want you to try out number 3 because I tend to get lots of different answers for this. So I want to see how you're feeling this out and kind of seeing what's what here. So I will show back up here in a moment. I'm going to give you 2 options when we come up here in a sec and see which one you think is the better choice for us here. So let's see. So there's 2 options. One's right, one's not. They're not interchangeable. Which is the one I want? The top one or the bottom one? Really bottom. Any voters for top? Any? Because here's our issue. 8 less than. I'm taking away the 8 is the way that's speaking. So if I'm taking the 8 away, if I write it this way, I'm taking the 5x away. So that is not what I want in this case. Darn less than. If we just got rid of that, we wouldn't have to worry about these things. So read through it and kind of, when you write it out, kind of look back one more time and go, okay, is this what this actually says, or is it slightly different? So got to be cautious on that one. All right, let's see. Rohini took her dog Rosie to the vet. The visit was $80. Okay, the visit was $80. Plus $15 per vaccination. Okay. When you see the word per in any sort of a word problem, that's going to be your variable, whatever your variable happens to be. Maybe you chose to make it V this time for vaccination. I don't know. So, plus vaccination. The total bill was $125. So not at least, not at most, it just was. So that's equals. Define a variable. You're like, okay. So let me start kind of making this clear early in the year for us. When we're labeling variables, okay? Well, what if I just put X equals vaccinations? Okay, so is that the cost of the vaccination? Is that the number of vaccinations? Is that the number of options you have for vaccinations? You've got to be specific. So here, I know how much the vaccinations are, so I know that's not it. Oh, it's the number of them. So if my dog had to have 4, this becomes 4. If my dog only needed 2, this number becomes 2. But be very specific, because when you're not, you leave people open for all sorts of interpretations. And that's usually not a good thing. So that's all we had to do here. We don't have to solve it, I don't think. Nope, just write an equation. We don't want to make more work than we need to. And kind of work that through. So these last couple that I want to play with, okay, again, is going to come back to how good is our focus on detail. So here's what we mean. Michaela's mom gave her $120 to spend on clothes. Okay, that was nice. She bought 3 pairs of jeans that were on sale for $24 each. Then she found some shirts for $18 each. Define a variable and write an inequality to show how many shirts she can get. Okay, so this is just me. Everybody's got to do their own thing. I like to put things in words before I start putting numbers with stuff. So to me, I look at this and I say, okay, she bought some jeans and she bought some shirts and she's got $120 at most to spend, so she's got to be less than or equal to 120. That's just kind of my game plan here. So now that I get that, now I'm going to go back in and put numbers to things. So I'm like, all right, she bought 3 pairs of jeans that were $24 each. All right. So she bought 3. I mean, yes, could I just put 72? I could, but again, I'm trying to kind of work my way through here. Then she found some shirts that were $18 each, but I don't know how many. There's my variable. Define the variable. I don't like using S for a variable because my S's and my 5s get mixed up sometimes. We don't want that happening. So there basically is my inequality. I mean, I'm going to simplify this because again, write an inequality. It doesn't say solve. I'm not doing more work than I have to. You don't tell me to solve it. I'm not solving it. I could. Now let's see, 7. Yeah, see, that's not going to go in evenly. That'd be a fun thing to answer sometime. And like, how many can I buy if it says 2.5? And then use a little common sense. But we're just writing right now. We're just writing. Okay. A couple more. Again, we got to be able to play with words too. The English people don't have to play with numbers, but we got to play with words. Not quite sure that's fair, but it is what it is. Okay, a real estate broker's basic salary is $18,000. Ouch. She earns a 4% commission on sales. How much did she sell to earn $55,000? To find a variable, write an equation. Oh, we got to solve this time. Okay. So again, you're going to find consistency with me. I'm going to do a little word salad here first. So let's see. So I'm going to get a salary. So that's $18,000. I'm getting that no matter what, whether I'm good at this thing or not. I'm getting $18,000. Okay. She gets a 4% commission. So if I'm good at this and I sell some houses, I'm going to get a commission. So I'm going to get 4% decimal. Again, whenever you're dealing with percentages, you're just dividing them by 100, moving the decimal point 2 places to the left. Got to do that part, though. On total sales, doesn't say anywhere how much she sold. So there's our variable. How much did she sell to earn $55,000? So if you have some background with this, you'd know that if you have a salary position where you earn commissions, those two things together are going to equal your pay. You're not making an hourly rate. So in this case, we're trying to figure out what do I have to do to make my pay what I want it to be in this case, which is $55,000. Okay. This shouldn't be bad at this point. Hopefully. So if we're solving for x, we'll get that 18,000 out the way. We'll subtract that out. And since we're multiplying by 400ths, this 4% is a decimal. Let's see here. Oofda, that's quite a bit. All right. So she's going to need to sell $925,000 worth of real estate in order to earn enough of a commission for the yearly pay to be $55,000. But again, if you can go straight to the equation, that's fine. But sometimes just putting words to things can help out quite a bit with not getting things mixed up into different spots. Okay, one last one. Oh, we got to solve again. All right, we got this. But you kind of see the pattern developing here of if you kind of take the time to plan ahead, you're going to keep yourself out of trouble. Okay, we're going to organize a benefit concert. That's a good idea. We're going to have 2 types of tickets, adult and child. That's feeling like variable terms, but we'll see. Your goal is to sell $25,000 in tickets. Okay, so there's our sales. You're going to charge $25.25 per adult and expect to sell 800. You need to determine, okay, what to charge for child tickets. That's a variable. So let's see. So C, maybe. This again is where I have to be specific. I can't say child tickets. Does that mean the cost? Does that mean the number? Well, I know how many. So it's definitely the cost or the price. So if I want to go back again, I'm like, okay, so I got some adult tickets, and I got me some child tickets, and that's going to get me my total. If I wanted to be like really, really general, I mean, I could put revenue because it looks like I know tickets and prices. So if I want to know how much the adults are bringing in and how much the children are bringing in to get me to my total, which I know is 25,000. If you've ever done anything with events where you sell tickets, we know that if you take how much a ticket costs times the amount of them I have, that lets me know how much I'm making there. So I have both numbers for the adult, but the child, all I know is how many tickets. I don't know what to charge, at least not yet. Ooh, that's a good question. Okay, I'm with you on that. Let's do that. The only thing that I would say would be different, actually, now let me think. Well, we'll rediscuss that in a minute once we do this last part, because then we'll see if we want to go that route or not. We might change that back. We'll see. So we got 20,200 plus 300C. And now we have the mystery symbol in the middle here. Am I going to go back to equals? I'm not going to yet. Let's stay here for a second. So I start to work through, and I go, okay. So subtract that 20,200 over. And to find C, I've got to divide by 300. So now here's where we're going to be able to have the discussion about the symbols. Depending on how you want to look at it, but we'd all have to have an agreement on this. So here, if I keep it as greater than or equal to, I'd say, okay, I need to charge at least $16 for a child ticket if I want to have $25,000 ticket sales, which is a legitimate thing to say here. So if you wanted to keep it that way, you could. If you're like, hey, I just want to know bare minimum. If I want to hit 25,000 and I'm content there, I'm just going to put equals. So I wouldn't fight either of those. I'll have people out there that would just absolutely obliterate me for saying that way. But here's my other thing. Here's one hint on where the writer of the question probably was heading. Because if it was going to be or equal to, they'd probably say write an inequality here instead of an equation. But again, I absolutely see where you're coming from on that. So I'm okay with either of those. Yeah, unless we are just blatantly off on something, most of the time we're gonna leave ourselves open to quite a few of those things. So I like this. I like this. Any other question so far? That was a good one. Okay. So as we flip back here, this always gets interesting. Because literal equations are when everybody always says, when am I ever going to use this in life? My answer most of the time is going to be, or not, it's going to be, we're teaching problem solving and sticking to it and all that stuff. With several of these, sometimes you'll get into some actual equations, business, technology, things that you actually could be useful. So we're doing a little rearranging here. We're going to do all the same operations we do for a regular equation, except now there's going to be extra variables involved. Other than that, don't let this freak you out. So, here's what I mean. Solve for the indicated variable. Okay, we're solving for y. So my goal is to get 3y by itself right away, or maybe even negative 3y in this case. So I look at this and I say, hey, that's a positive 2x. So I want to undo that. So we're going to subtract that out of there. You can either look at it as negative or subtract. They're interchangeable. But here's where I've got to be careful. These are not like terms. Okay? 12 minus 2x is not 10x. It's negative 2x plus 12. But now, Hardy, can I put 12 minus 2x? Yes. Okay. Your signs are still the same, so that's fine. And then my last step is just to divide by negative 3. Now, what does this answer look like? Well, it depends. If I'm just solving to solve, could I just leave it like this? Sure. I sure could. Or, and this is probably the way that I'm going to write it, and I'll even explain why. If I actually divide each of these terms by negative 3, negative divided by negative is positive, so 2/3 x. And 12 divided by negative 3 is negative 4. I would probably go this route. Why? That looks like if I was going to graph a line, what I would do. If I was going to substitute a value in, I'd rather have this. It just depends. So don't get to a point, though, if you put this for your answer and you look at my key and it's this, take a moment before you're like, well, I did it wrong. You might not have. It might just look a little different. So be prepared. Same type of thing as we move through. It's going to be weird sometimes, but it happens. Ooh. Solve for t, and t's in the denominator. Well, what the heck do I do here? Okay, let's think. We're dividing by 2t. What's the opposite of dividing? Multiply. So we're going to multiply both sides of this equation by 2t, because that will get my t out of the denominator. You're like, but Hardy, you canceled it out. We don't want to cancel it out. We don't want it in the denominator, though, so I moved it. 10 times 2t is 20t. Now my t's not in the denominator anymore. It's not in the dungeon. We have freed it. And now I can actually work on solving for it and getting it by itself. Multiplying t by 20, we do the opposite and divide. The biggest thing you have to be careful of when you're doing these problems is not looking for the opportunity for the simplest variable. It says solve for t, you multiply both sides by 2t and leave it. I'll have a lot of people do this in circle, and I'm like, what are you solving for? Oh, crap, I solved for s, I'm solving for t. So make sure you take it far enough to be able to do that. But now we've got to throw one twist in. Here comes the post-it note. Remember, the post-it note means something's going to go bad, so don't write this, because I'm going to take you down a bad road here for a minute. Now you would think this is the easiest problem ever. I'm solving for x. There's x. I'm just going to minus 7. X equals 2xy minus 7. Yay! Nope. What do you mean, no? You got x by itself. Here's the thing. And we're going to put a little note about this up in the top. When you're solving for a variable, that variable itself cannot be part of your answer. X cannot be part of the answer when you're solving for x. This doesn't work. So, a variable can't be part of its own answer. Okay? I'll even put number 5 here. So we have a reference point. So, okay, if that's not what I'm allowed to do, What the heck can I do? Well, I'm going to tell you. So we're going to get all the x's on one side together to start. So we're going to minus this x to both sides. So I subtracted it over. Now this is actually looking worse instead of better, but here's what we got to keep in mind. This is the first time of many this year that we are going to bust out the Algebra 2 F word. Not that word, but a different word that might make you feel the same way. Those two terms have something in common. An x, which I can factor out, which means if I take an x out of each of those, over here, if the x goes away, I still have 2y left. X times what would get me to negative x? Negative 1. So if I would distribute right now, x times 2y is 2xy, x times negative 1 is negative x. So you're like, okay, so what's the good of that? Well, look now. There's only one x left in my problem. It's like magic. So now I can solve for x. I'm multiplying x by all this stuff in the parentheses. So I'm going to divide by all the stuff. That all goes away. X is by itself. It's solved for, and it's not part of the answer. Amazing. We even make variables disappear. You get a magic show on top of everything else. This is awesome. We get to see how that works. So, yeah, that's always one that catches people by surprise. That's why we put the little extra here. And I'm already going to change on the fly. We're not going to deal with 1.4 at all because that's just going to get to be a little crazy. So number 7, last one to play with for now. Like I said, if you're interested in seeing some of the other ones as well, I'm going to post those once I'm off after advisory here. I'll get those up for you as well if you want to see some of those at work. Okay, so number 7, last one for the time being. Solve for x. Okay, we only have one x. Hallelujah. So we're going to minus the 6y out of there. And again, I don't care if you have 14 minus 6y, negative 6y plus 14. I'm just used to looking at it this way. X is not alone yet. Okay, we're still multiplying it by 2. We've got to undo that. Let's see here. Negative 6 divided by 2 is negative 3. 14 divided by 2 is 7. Ooh. Okay. What's the opposite of squaring something? Square root. Now, here's the kicker. Here comes the part people forget. Well, a couple things. When you have what's called a quadratic, an x squared, that exponent tells you how many solutions there are. In this case, there's 2. Well, my answer only has 1. So whenever you have an x squared and you square root to get your variable alone, you've got to put plus minus on the answer because there's 2 answers. I'm not going to push the envelope further than that right now. When we get to the quadratic section, there's a restriction I'm going to have to put on it, but I'm not doing it yet. I'm not doing it yet. For now, you can have it there and see what's going on and be content with that. Okay, we'll deal with the rest later. So just a couple of those little things to play with. So, like I said, we're going to adjust on the fly with the assignment here. I'll update it on the calendar too. So here's what I'm looking for you to be up to here. We'll get all the inequality stuff in tomorrow. So in the practice, I'll even put that up here so we keep things straight here. Okay, translating word problems. Here comes all the setup and solve and all that stuff again. I'm going to tell you the same thing I told you before, which is I would start with odds because you've got answers for those on the back. Do your odds, make sure they're going well. If you feel comfortable at that point, great, you're good. If there's anything you're still iffy on, play with some of the evens, and you can always see me about checking in and making sure some answers are good on that front. But that's what we'll look at, and then we'll just do all of 1-4 tomorrow instead of doing bits and pieces, and we'll make it